Hey, Raz here, and today we'll be looking at the June 2024 paper R that we did in the mock. So as requested, we're just going to look at some of the back questions. So we'll start with this one, sum of an arithmetic sequence. We go to the front of the book, we've got the formula booklet, and it is this formula that we need here. So I'm going to write that in the corner because we'll need it in a minute. So Sn equals n over 2, 2a plus n minus 1 d. Let's go back to the question. So here we are. So to use this formula, we need to know the number of terms, which we're given in the question is 40. And we need to know the first term and the common difference. So the significant thing here is it's an arithmetic sequence, which means the sequence is linear, which means it's additive. It's going up by plus the same difference each time, whether that's a positive number or negative number. So if you imagine the sequence 2, 4, 6, 8, which is another linear sequence, if I take 2 away from 4, I get 2. If I do 6 take away 4, I get 2. If I do 8 take away 6, I get 2. Which is a property that will happen with any part in the sequence. So using that bit of knowledge, we know that if we do x plus 2 minus 4x minus 14, that'll give us the same answer as if we did 7x minus 9, take away x plus 2. So you have to be careful with the negative signs here because that can cause some mistakes. So we have x plus 2 minus 4x plus 14 equals 7x minus 9 minus x minus 2. So that gives me minus 3x. That gives me 16. That gives me 6x. And that gives me minus 11. So if I move this to the other side, I get 9x. And if I move this to that side, I get 27. So conveniently now, x is 3. So now we know x is 3, we can figure out the values of the sequence by subbing in x is 3. So the first term must be 4 times 3 minus 14. So 12 minus 14, which is minus 2. The next term is 3 plus 2, which is 5. And the third term is 7 times 3 minus 9. So 21 minus 9, which is 12. Yeah, so this is now our first term. And the common difference is what it's going up in, which is 7. So now we're in a position to use the formula. So the sum of the 40 terms is the number of terms divided by 2, multiplied by 2 times the first term. So 2 times minus 2, plus n minus 1d. So 40 take away 1 times the common difference. And the common difference was 7. If we neaten that up, we have the sum of the 40 terms is 20 minus 4 plus 39 times 7. And that will give us the answer. At that point, I'll get the calculator out. For some reason, it's not getting out. And we will get 39 times 7 minus 4 times by 20. And we get 5387. Yep, so there's that answer. So let me just load my calculator up. Right, next one, 22. And we want to find the angle BMP. So let's draw that triangle first. So we have a B, an M, and a P. And that angle there is what we need to answer the question. So if I just annotate on the diagram, BMP is that triangle there. So ideally, we need to figure out what that length BM is, which we can do by creating this triangle here. So the triangle, right angle triangle ABM contains the length BM, which we can find by using Pythagoras' theorem. Yes, so AM is half of this total length here. And that total length will be, so AM is half of AE, which is half of the square root of 12 squared plus 20 squared. There's my calculator. So if we do the square root of 12 squared plus 20 squared, we get that. So 4 root 34. I'll leave it like that. So we've got half of 4 root 34, which will be 2 root 34. So this length here, AM, is 2 root 34. And we know that the height of the triangle is 8. Yeah, we can see that there. So now we can use Pythagoras again to figure out the length BM. So it'll be the square root of 2. So we have 2 root 34 squared plus 8 squared square rooted. So we get 10 root 2. That's 10 root 2 there. So BM is 10 root 2. So I now have to do the same process to figure out the length of MP. So let me move this calculator out of the way. So MP is here. Yeah, and that's that midpoint there. So we could create a triangle here and here. So suddenly we know the height is 8, and that base length must be 6. Job done. So PM is the square root of 6 squared plus 8 squared. Get my calculator out. Square root of 6 squared plus 8 squared. This will be a nice answer that we'll all like. Get 10. So then, if I fill in what I had to start with, that's 10. So we have MP, BM, but also need BP. So BP is, so I need one more length. Which is that one. Yeah, but we can see that that is part of this triangle here. So we know this is 12 and this is half of 20, which is 10. So BP equals the square root of 12 squared plus 10 squared. So BP is square root of 144 plus whatever. So square root of 12 squared plus 10 squared equals, so 2 root 61. Now we could decimalize it, but I don't want to get rounding error. So but if you prefer decimals, put 15.62. Not my style. I'm going to put 2 root 61. There, 2 root 61. So now we're in a position to solve the question. So from the cosine rule, rearranged, we know the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. We rearrange that, we get cos a equals b squared plus c squared minus a squared all over 2bc. And we just need to sub those numbers in. So if this is our angle A, that will be length A. And then these will be our B's and C's. Yes, so cos A equals 10 root 2 squared plus 10 squared minus 2 root 61 squared all over 2 times 10 root 2 times 10. And then we're going to do cos inverse of that, and that will give us the answer. So let's do that. So we have 10 root 2 squared, 10 root 2 squared minus 10 squared. Plus minus 2 root 61 squared all over 2 times 10 root 2 times 10. And then we shift cos answer. And we get 78.6, job done. Easy as that. Yes, there's a lot of Pythagoras in there. And then we just use the cosine rule once. Okay, so now let's look at question 21. So the 25 counters in the bag. So blue, we have 6. Orange, there are X counters. and pink is the rest. So pink must be 25 minus 6 minus x, which is 19 minus x. Yeah? So Marlon takes two counters from the bag. The probability that one is orange and one is pink is 22 over 75. So it doesn't specify an order. So what it's saying is orange, pink plus pink, orange equals 22 over 75. So the probability of getting an orange and a pink is x out of 25 times by 19 minus x over 24. And the probability of getting a pink and an orange is going to be 19 minus x over 25 times x over 24. So you can see we've got the same numbers. So OP plus PO equals 22 over 75 means we've got this plus this. And since the numerator is the same thing, that just essentially means we've got two lots of x times 19 minus x. Yeah, all over 25 times 24 equals 22 over 75. So if I times by 75, that will get rid of this 25, and 75 divided by 25 is 3, so I'll get 3 there. And that disappears. Then I times by 24, that goes there. So what do we have? We have 6 times 19x minus x squared equals 22 times 24, which is 528. So 6 times 19 is 114, minus 6x squared equals 528. So we need to solve this quadratic equation. So if we use the quadratic formula, x equals minus b plus or minus square root of b squared minus 4ac all over 2a, we will get the solution. So fraction button, set up 1. So we've got x equals minus b, so minus 100, minus 114, plus or minus square root of b squared, minus 4 times 6 times 528, all over 12, 2 times 6. So I get 11. And then the other one, I'll change that. Is 8. So it says orange is bigger than 9. So we know there's 6 blue, 11 orange, and pink is 90 minus 11, which is our second answer, which was 8. So calculate the probability that Marlon takes 2 pink counters from the bag, so we can now re-answer the question. Just I need to rush now because I just realised I need to be on duty. So pink is going to be 8 out of 25 times 7 out of 24, which is 56 out of 520. Oh, no, it wasn't. 25 times 24 is just 600, isn't it? Yeah. Which simplifies to 7 over 75. Okay. All right, I'm off the duty now. Bye. Okay, so now on to question 20. So this is a completely square question. So a lot of you remembered kind of what to do, but didn't execute. First, we take this constant out because it's annoying. So we get this. Now, what you have to remember is we haven't completed the square yet. So we need to now complete the square on the bit that's in the square bracket. So x squared minus 11 over 2x will become x minus half of 11 over 2, which is 11 over 4, squared minus 11 over 4 squared. So we get this. So we need to reinsert that into the square bracket. Yes, if I put here, now we can complete the square. Blah, blah, blah. Now we can complete the square. We have x minus 11 over 4 squared minus 121 over 16 plus 9. So when I times by 2, it's going to go there. And I have 121 over 16 squared, which would be 121 over 8. I'm plussing 9, and 9 is the same as 72 over 8. And so I get my answer. Over 4 squared minus 121 plus 72 is minus 49 over 8. There's your answer. Yes, so obviously I can write that on the line, but I haven't. There you go. Yeah. You just check I haven't done anything wrong. No, yeah, that's it. That's definitely it. So I hope that makes sense. So for part B, we've got a few methods we can do this one with actually. Find the coordinates. So P is the minimum point of this. Yeah. So if we look at this, the minimum point would be at 11 over 4 and minus 49 over 8. Yeah. So if I clear this, we're now just going to amend our answer. So, because the difference between this and the original equation is the graph is moved 3 to the right. If we compare the question, it's exactly the same. Instead of having x, it says x minus 3, which is a graph transformation of 3 to the right. So if our minimum point originally was at 11 over 4 and minus 49 over 8, then if we move this 3 to the right, it's going to affect that coordinate. Yes, so the new minimum will be 11 over 4 plus 3, and 3 in quarters is 12 over 4, but the height of the coordinate will stay the same. So the answer will be 23 over 4 and minus 49 over 8. Done. Now, if we didn't realise this, we could have used our old friend differentiation. I'm going to get exactly the same answer. It's going to take me a while to do it this way. Actually, I'm not going to do it that way, it's just silly. But we could use differentiation, but just take a while. But from what I've said, you know, for those 2 marks, we get that answer. Now, one of the reasons I ducked doing differentiation there is because I'm going to need it. This question. Yep. So, soon as we see stationary points, we're differentiating. So, if the original function is x cubed minus 8x squared minus 12x plus 5, then when we differentiate, we get 3x squared minus 16x minus 12. Now I want to know where that's a stationary point, so I set that result equal to 0 and solve it. Yeah, so I need to solve this. Yeah. So I was just thinking about factorizing. So we could use it solved by formula. Yeah, let's solve by formula. So x equals minus b plus or minus the square root of b squared. So 16 times 16 is 256, I believe. Minus 4 times 3 times minus 12. 4 times 3 is 12. 12 times 12 is 144. All over 2 times 3. So if we whack that into the calculator, I've simply done a fair bit of simplifying there to make my life easy at this point. Square root of, what's that going to be, 400, which is just 20, all over 6. So I get 6 and minus 2/3. Well, we're told that curve C has 2 stationary points, one at A, one at B, such that A is bigger than B. So that must be A, that must be B. Find the coordinates of A. Nice. So we know x is 6, and then we have to substitute into the original equation to find out the corresponding y value. So if I sub into the original, I've got y equals 6 cubed minus 8 times 6 squared minus 12 times 6 is 5. So 6 cubed, I think, is 216. It is. 36 times 8 is 288. 12 times 6 is 72 plus 5. So we can just bash that into the calculator. 216 minus 288 minus 72 plus 5. We get minus 139. That's our coordinate of A. All right, and then that's question 19 and 18. So I think this will be the last one of these harder questions that we do. So many of you remember to do length, area, volume. Why not just use a line? Length, area, volume, and we have shape, A, B, and scale factor. Yeah, and the scale factor is what we call K, K squared, K cubed. So the height is a length, is 30, and the height of B is 12. So if we do 30 divided by 12, we'll get like 2.5. Now let's just do that squared whilst we're there. And that gives us 6 1/4. 6.25, and if we times that again by 2.5, we'll get our k cubed. So 6.25 and 15.625. So that's what we've been given so far. Now what it says here is the surface area of A minus the surface area of B is 778.5. So the surface area of B would be my x, because I don't know what it is. If I times that by 6.25, I'm going to get the surface area of A. It should be 6.25x. So what this is telling me is 6.25x minus x must equal 178.5. Well, 6.25 minus 1 is 5.25. So now if we do 178.5 divided by 5.25, we'll get 34. So x is 34, which means I can put in 34 here. And so the surface area of A is simply 6.25 times 34. Yeah, because if I times that by k squared, I'm going to get that missing amount. So times 6.25, and we get our answer, 212.5. Okay, so that completes mock paper 1, the hard questions. And next video will be the hard questions from paper 2, and any subsequent video will be questions you've asked me to do. All right, see you later, guys.